Space is a vast expanse of mysteries and discoveries, a realm that has intrigued humanity since the dawn of time. It stretches far beyond what our eyes can see or our minds can comprehend. Yet with every discovery, we realize how much more there is to learn. Today, we will explore 7 mind-blowing facts about space that will leave you questioning everything you thought you knew about the cosmos. From freezing nebulae to wandering planets, these revelations highlight the universe's endless complexities and its extraordinary power to surprise us. Let's dive into this fascinating journey and unravel the secrets that lie beyond our world. Our first topic takes us to the Boomerang Nebula, known as the coldest place in the universe. Nestled roughly 5,000 light-years away in the Centaurus constellation, this nebula astonishes scientists with temperatures that plunge to a staggering 1 degree Kelvin above absolute zero. This temperature is colder than the vacuum of space itself. Such extreme cold results from a dying star ejecting gas at extraordinary speeds, causing the material to cool rapidly as it expands into the surrounding void. The Boomerang Nebula's unique conditions make it a natural laboratory for studying how matter behaves near absolute zero. These studies could help us understand phenomena ranging from superconductivity to quantum mechanics. Imagine standing in a place so cold that molecular motion almost ceases entirely. What would this frozen silence feel like? Beyond its scientific implications, the nebula's ghostly shape, resembling a bow tie or boomerang, makes it one of the most visually striking celestial objects ever observed. It is a testament to the universe's diversity, reminding us that even in the harshest conditions, beauty can thrive. Next, let's turn our attention to the enigmatic phenomenon of rogue planets. These solitary wanderers drift through the galaxy unbound by the gravitational pull of any star. Unlike the planets in our solar system, which orbit the sun in predictable paths, rogue planets are free agents, moving aimlessly through the darkness of space. Scientists estimate that billions of these planets exist in the Milky Way alone. Some may be remnants of planetary systems that were disrupted, ejected from their orbits during cosmic collisions or interactions with massive celestial bodies. What makes these rogue planets even more intriguing is the possibility that some of them could harbor life. Without a star to provide heat and light, how could life exist? The answer lies in geothermal energy. Certain rogue planets may have molten cores that generate enough heat to sustain subsurface oceans beneath thick layers of ice. These hidden oceans could provide the perfect conditions for microbiology to develop and thrive, much like we suspect might be happening on moons like Europa and Enceladus in our own solar system. This challenges the long-standing notion that life requires sunlight to survive, expanding the boundaries of astrobiology and the search for extraterrestrial life. Imagine a planet shrouded in perpetual darkness, its surface frozen and barren, but beneath the icy crust lies a thriving aquatic world, teeming with life forms adapted to complete isolation. The discovery of rogue planets not only reshapes our understanding of planetary systems, but also forces us to rethink where and how life might emerge in the cosmos. Let us now journey into the captivating world of fast radio bursts, or FRBs, a phenomenon that has puzzled scientists since its discovery. These brief, yet incredibly powerful flashes of radio waves originate from distant galaxies, some billions of light-years away. Lasting only a few milliseconds, a single FRB can release as much energy as the sun does in an entire day. Their fleeting nature and immense power have sparked a whirlwind of theories about their origins, ranging from natural cosmic events to the tantalizing possibility of signals from advanced extraterrestrial civilizations. Sounds like the hollow emblems Clarin officiated to dive underwater. Bosch said, "One of the most fascinating aspects of FRBs is their diversity. Some are one-time bursts occurring suddenly and disappearing without a trace. Others, however, are repeaters, emitting signals multiple times from the same location. This repetition suggests that their sources are not catastrophic events like supernovae, but rather ongoing phenomena. One leading theory posits that repeating FRBs may be caused by magnetars, highly magnetized neutron stars that emit intense bursts of energy. Another hypothesis suggests that they could be linked to black holes or even the collision of neutron stars. The idea that FRBs might be extraterrestrial in origin adds an extra layer of intrigue. Imagine if these signals were deliberate attempts by another civilization to communicate across the cosmos. While there is no concrete evidence to support this theory, the mere possibility has inspired countless discussions and debates among scientists and the public alike. With advancements in radio astronomy, such as the CHIME telescope, our ability to detect and analyze FRBs is rapidly improving. Each new detection brings us closer to unraveling the mystery behind these enigmatic bursts and understanding their role in the vast tapestry of the universe. Our next topic delves into the awe-inspiring phenomenon of supermassive black holes, the mysterious titans lurking at the centers of most galaxies. These cosmic giants, millions to billions of times the mass of our sun, possess gravitational pulls so immense that nothing, not even light, can escape once it crosses their event horizons. Among the most famous is Sagittarius A, the supermassive black hole at the heart of the Milky Way. While invisible to the naked eye, its existence is revealed through the movements of nearby stars and the intense radiation emitted by matter spiraling into it. Black holes, particularly supermassive ones, are not just cosmic vacuum cleaners. They play a fundamental role in shaping galaxies, influencing their formation, and even determining the rate at which stars are born. For example, the interaction between a black hole and its host galaxy can create jets of high-energy particles affecting the surrounding environment for millions of light years. Recent breakthroughs, such as the historic image of a black hole's event horizon, have given us a glimpse of these enigmatic objects like never before. This achievement was made possible by the Event Horizon Telescope, a global network of radio observatories working in unison to capture the elusive shadow of a black hole. Despite these advancements, much about black holes remains a mystery. What lies beyond their event horizons? Could they be portals to other dimensions, as some theories suggest? Or do they simply compress matter into an infinitely dense point known as a singularity? These questions continue to inspire scientists and fuel the imagination of anyone captivated by the unknown. Supermassive black holes stand as both the ultimate enigma and a testament to the universe's extreme and beautiful nature. Continuing our cosmic exploration, we move into the extraordinary diversity of exoplanets. These planets orbit stars beyond our solar system, and the sheer variety among them is nothing short of breathtaking. Scientists have discovered thousands of these distant worlds, and each new finding expands our understanding of planetary systems. Exoplanets range from gas giants, many times the size of Jupiter, to rocky, Earth-like worlds, and everything in between. Some even challenge the boundaries of what we consider possible. Take, for example, the planet HD 1897333b. This so-called hot Jupiter is located about 63 light-years away and is infamous for its extreme weather. Winds on this planet can reach speeds of over 5,400 miles per hour, and it rains molten glass carried sideways by the ferocious gusts. Then there's Kepler 10b, a rocky world so close to its star that its surface is covered in oceans of lava, with temperatures hot enough to vaporize rock. Meanwhile, planets like WASP-12b are slowly being devoured by their parent stars, their atmospheres stripped away due to intense radiation and gravity. But not all exoplanets are extreme. In the habitable zones of distant stars, we've identified planets with the potential to harbor life. These Goldilocks planets sit at just the right distance from their stars, where conditions might allow for liquid water, a key ingredient for life as we know it. Worlds like Proxima Centauri b, orbiting the closest star to our Sun, have sparked interest as potential homes for extraterrestrial life. The study of exoplanets is one of the fastest-growing fields in astronomy. With missions like the James Webb Space Telescope and the Transiting Exoplanet Survey Satellite, TES, we're poised to uncover even more about these fascinating worlds. The discovery of exoplanets reminds us that our solar system is just one of countless planetary systems in the galaxy. It sparks the imagination, making us wonder what other forms of life or extraordinary landscapes might be waiting to be found in the universe. Now, let's explore the concept of time dilation, a phenomenon so mind-bending that it feels like science fiction, yet it's a proven reality rooted in Einstein's theory of general relativity. Time dilation occurs in the presence of intense gravitational fields, or at extremely high velocities, causing time to pass more slowly for an observer in those conditions compared to someone farther away. It's a phenomenon that has been verified through experiments on Earth and in space, demonstrating the remarkable interconnectedness of space, time, and gravity. Imagine a spacecraft venturing close to a black hole, where the immense gravitational pull bends not only space, but time itself. For an astronaut near the event horizon of the black hole, time would pass far more slowly than for someone observing from a safe distance. In essence, an hour for the astronaut could equate to years or even decades for those waiting back on Earth. For more important news than a deep dive into the black hole, this phenomenon was famously illustrated in the movie Interstellar, which drew directly from real physics to depict the effects of time dilation near a massive black hole called Gargantua. But time dilation isn't limited to black holes. It also occurs at much smaller scales, such as in our satellites orbiting Earth. The Global Positioning System, GPS, which relies on precise timekeeping, must account for time dilation caused by both the satellite's high speeds and the weaker gravitational field they experience compared to Earth's surface. Without correcting for these effects, GPS calculations would drift by several miles each day, rendering the subject unaware. Time dilation is more than just a curiosity. It has profound implications for the future of space exploration. If humanity were to embark on interstellar journeys at near-light speeds, the travelers might experience significantly less time than those remaining on Earth. This creates fascinating, albeit complex, scenarios for the nature of communication, aging, and human relationships across vast, cosmic distances. This strange bending of time challenges our perception of reality and underscores how much of the universe remains to be understood. It also raises questions about the limits of human ingenuity. Could we one day harness the principles of time dilation for practical purposes? Or might it become an obstacle to overcome in the quest for interstellar travel? These are the questions that fuel not just scientific research, but also the dreams of those who look to the stars and imagine what lies beyond. Finally, we arrive at the Great Attractor, one of the most mysterious and imposing forces in the known universe. This gravitational anomaly, located in the direction of the Centaurus constellation, is so massive that it's pulling galaxies, including our own Milky Way, toward it at incredible speeds. To grasp the scale of this phenomenon, imagine inexorably toward this shockingly billions of stars, all being drawn inexorably toward this enigmatic point in space. The sheer magnitude of the forces at play defies comprehension and underscores just how interconnected the universe truly is. But what exactly is the Great Attractor? Despite decades of study, its true nature remains elusive. Part of the challenge is that this region lies behind the zone of avoidance, an area obscured by the dense disk of the Milky Way's stars and dust. This makes it exceptionally difficult for scientists to observe directly. However, what we do know is that the Great Attractor exerts a gravitational influence so profound that it's altering the motion of thousands of galaxies in its vicinity. Some researchers theorize that it could be a supercluster of galaxies, while others propose it might be an even larger structure, possibly tied to the vast cosmic web of matter that connects the universe at its largest scales. This gravitational anomaly also raises important questions about the unseen forces shaping the cosmos. Is the Great Attractor primarily composed of visible matter, like stars and galaxies? Or could dark matter and dark energy, those mysterious substances that make up the majority of the universe, play a significant role in its immense pull? The answers to these questions could revolutionize our understanding of the universe's structure and evolution. The Great Attractor is not just a subject of scientific inquiry, it's a reminder of how much of the universe remains a mystery. Despite all our advancements in technology and understanding, we are still uncovering the fundamental forces that govern existence on a cosmic scale. This sense of wonder and discovery is what drives astronomers and physicists to continue exploring, pushing the boundaries of what we know, and daring to dream about what we might one day uncover. As we conclude this journey through some of the most mind-blowing facts about space, one thing becomes abundantly clear: the universe is far more complex, beautiful, and mysterious than we could ever fully comprehend. Each new discovery not only deepens our understanding, but also expands the horizons of what we consider possible. From the coldest nebula to the solitary wanderings of rogue planets, from mysterious radio signals to the immense pull of the Great Attractor, space invites us to marvel, question, and explore. Which of these facts resonated with you the most? Do you find the idea of rogue planets intriguing? Or are you captivated by the mysteries of the universe and exploring the wonders that lie beyond our reach? And if you enjoyed this exploration of the cosmos, don't forget to subscribe to Mystery Solved for more incredible stories and discoveries. Together, we'll continue unraveling the mysteries of the universe and exploring the wonders that lie beyond our reach. Thank you for joining us on this journey, and until next time, keep looking up at the stars.